Hello, welcome to DrawExact's Getting Started Guide. I know that most people, when they're confronted with a new piece of software, particularly if you're very confident, will say, I'm just going to learn how to use it by experimentation. But I'd like to urge people to not do that in this case, because DrawExact works in a really quite a different way from most software that's gone before, for very good reasons. We've done it to try and create a great user experience using it, making it fast, capable, pleasant, efficient, and so on. So if you would please bear with us while we just explain a couple of the operating concepts, you'll have a much better time and not get frustrated. It's actually really easy to use, but it's a bit different, so we've just got to show you how to get started. The video is in two halves. The first half is me trying to explain all the basics, and then the second half is me demonstrating some of the slightly more exotic features, which you can either carry on watching, or you can they're all discoverable if you prefer to find it your own way. And you can either just watch and listen to me doing this, or you can sing along if you like, because this drawing is one of the built-in drawings in DrawExact. So if you want to, you can just try things out in the same order as I'm doing them and pause the video in between. Totally up to you. So the first thing you need to know how to do is how to zoom in and out to move around the drawing. And to zoom in, what you do is you click and drag, start clicking and dragging a window like this. And you'll notice that there's a prompt following the bottom right-hand corner of that box, which gives us two choices, and that's always the case. Either we just release to zoom in, which is what I'm just about to do, and I'll explain what the other option is for in a minute. That's kind of the first difference, really. So there we are, we've zoomed in. I'll zoom back out, and we can zoom in to any level, any depth. And to zoom back out, I'm doing this zoom out command, the zoom to fit command, which is keystroke Z for zoom to fit. Zoom to fit, zoom in, zoom to fit. You can also do zoom out to zoom out in little increments at a time. O is for out, zoom out. So if I go out, 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 zoom to fit. You get the idea. So that's zooming navigation. The next thing that I wanted to show you, where's my script? I keep losing it. Right. Let's say we wanted to draw a line from that point to that point. I select the points between which I want the line to travel, and then I do the line command up here. Line. You might think it doesn't get more simple than that, but actually it does. Because once I've selected the 2 points, I don't actually have to go over here and press line, because L is for line. L is for line, A is for arc, T is for text, R is for rectangle, D is for delete, G is for grow. I think you get the picture. So although this helps you learn, it's much quicker and more intuitive to just say, right, I want a line, L for line. So when you're thinking line, your finger just tends to move to the L key. And it doesn't have to be these exact points, it can be just a line in the middle of nowhere. U for undo. So that's a point-to-point line with points that already exist. But of course a drawing app has to offer several different ways of letting you draw a line, because there's lots of different situations where other methods are much more convenient. One of the very common ones is making a line that's parallel to another line. And that's, so say for example this line, say we wanted a parallel copy of this line which was offset so that it passed through that point. I can say line, point, and then just do the line command again, L for line. And that line is parallel to that one, and it would pass through that point, which I'll just digress to show you the grow command to prove it. Here's a line I want to grow. I want it to grow until it reaches level with that point, G for grow. So that's the parallel line, and you'll notice that I used the same line command for both of those, and it knew what to do based on what I'd selected. And each of the commands has a little explainer on there, question mark, and I've just shown you a point-to-point line and a parallel line. I'll just demonstrate one of the others, and you can read about the final one. A point to arc tangent. So that's saying, what if I want a line which goes from that point to this arc and meets it at a tangent, L for line. There's two solutions, so it's given you both of them. You just delete the one you don't want. And arcs behave very much in the same way. My favourite is arc through 3 points. So say for example I wanted to start there, to pass through this point and end up back at the top of that circle. A for arc. You've got to love that one. You could do parallel arcs just the same as parallel lines, and you can do full circles very easily. And there's also a more advanced way of creating arcs called a fillet radius, but that'll be in the second half. Undo, undo, undo. Excuse me while I go back to my script until I've remembered it. Right, we need to talk about selecting things to do something with them, like if we want to delete some stuff or if we want to move some existing part of the drawing. First of all, let me just show you how you select various things. You can select lines, arcs, text. Well, you can select lines, arcs and text, any number of them like that by clicking them. And then if I were to do D for delete now, they're deleted, U for undo. And it's useful to know that if you very carefully have clicked several things and then you realise you've clicked one thing you didn't mean to, like maybe that text, you can click it again and it'll unselect it, rather than having to do it all again. You can just clear all your selections by pressing escape, that's sometimes convenient. You can also do a box select. So do you remember that click and drag zoom gesture we were doing before, and I said I'll explain what the second option was to release it? So either release it to zoom in, which we've seen, but that second part of the prompt is saying that if I press space, that will select everything that's inside the box, like that. And so if I did D for delete now, it would delete it, U for undo. But you might also use it for something like the move command. So if I select it again, if I'm going to do the move command to move these selections, I need to define a move vector. So say I wanted to move it horizontally by that much. I've now given it all the information it needs, and I can do M for move, like that. Undo. So that's selecting things. What if we want to put in things of a fixed size, real precision? For example, what if I wanted to draw a line which started there and went horizontally along here about this far? And you can see from the coordinate readout that's wiggling as I move that at the moment the x coordinate is 12, 13. Say I wanted to come along here 15. What I can do is say 15 and then these rays. I better just explain the rays again. When there's nothing selected and I make a point, you get rays. You always get rays at your first point. You can have another point. In fact, you can have 3 points. But you can only have 3. As soon as you go to another one, it will forget the oldest one and move the rays onto whichever one is oldest. So often what you do is you just clear all your selections and then click a point, which is the oldest, and so you get the rays. And we said we wanted 15. Now I've already done that, so I can now just draw a line there. And that is 15 long. Rays are a kind of generalization for coordinates, both polar and Cartesian. I'll show you a bit about that. So if I start again here, these are 30-degree rays. I could have 45-degree rays and draw a line up at 45 degrees. But if I show you on a sloping line, you'll see that there's some even more interesting variations. If I say normals, let me just remind you what we were looking at. We've got a sloping line. I have no idea what angle that is. But if I say I want normals, I don't have to know what angle the line is because I've got automatically constructible normals. And say when this line came down here, I then wanted to carry on, but for it to veer off by about 10 degrees. What I can do is I can say, give me custom angle. I specify that it's 10 degrees, and now I've got a clickable point where I've now got that kink, which is a 10-degree deviation. Undo. So that's a very powerful generic coordinate system, all based on rays. But rays are very clever because they you've got clickable points at the end. It also snaps freehand points if you're close enough accurately to help you slide along the rays. But also crucially, if a ray intersects something like here, there's a clickable point, one there, and often you do that on purpose to get a point that's really useful. So that's how you put accurate geometry in using rays. And now let's talk about properties. Let's see what we could do to change the properties of this line. I'll select it and go P for properties. I could make it dashed. You see how it's showing a preview over here? Or chain. I'll go back to dash. I could make it a different colour. I could give it an arrow at one end and a blob on the other end. And I could say, oh, I really want those blobs to be a bit bigger. Which is very useful to make drawings where you want to use different colours to symbolise different things or create different levels of emphasis. Also, it's very useful if you want to carry on drawing other things in the same line style. If you select something that's got the style you like and you go K for keep, that'll keep the properties. And what that means is if I now draw something else, it will use the same properties. Undo. So that's properties on lines. It's the same for arcs, by the way. I could create this one into dashed line like that. And having showed you those properties, I want to talk about text because I had to explain properties before I could explain text. So if I wanted some text sitting on this corner, I specify the point and just go T for text. And it always says text 1 because the way it works is you know it's going to do that, and then you select it and do properties on the text and you fiddle with it over here. I could make it right justified or center justified or back to left justified. I can make it a bit smaller. I could stick it up at 5 degrees, which I won't do yet, but I just wanted to show you. And of course I can change the colour of the text. But what's really interesting is what you can do when you edit it here. And to show you that, I'm going to clear this box and I'm going to start some text in here. And I want you to see what happens when I start typing. You'll notice that it's got limited room to grow, this text. I'm going to start typing. I'm going to change this now. I'm going to. Now I can't fit the word change in without escaping the box. And I have manual control over this. So I go on to the next line. I'm going to change this. I can't fit on because. Now maybe I wanted this to be like a sub list. So I go on to the new line and go space, space. Reason 1, space, space. Reason 2, space, space. Reason 3. Quick properties. You'll notice that these, if you look at that G, all the letters underneath it are absolutely perfectly aligned. And that's by design. If I just pick up that line to use as a temporary ruler, you'll see if I put it there, that the lining up and the indentation is absolutely perfect. And that's because it's a special font designed just for that. And it's a bit unusual, but for drawings where you make blocks of text which have got to fit into awkward shapes, it's very, very handy. I'm just going to say a little bit more about the angle of text, because imagine we wanted to put some text along here, but at exactly that angle. I can measure the angle here using the same readout as before, 35.44 degrees. Properties. 35.44 degrees. So that text is now lined up exactly as per that line. I'm just going to show you how to do a copy and paste, but I'm not actually going to show you copy and paste, I'm just going to do it. I'll explain it in a moment. But what I want to show is how you could line it up like that. And that's, so you have completely in your gift how you angle text and make it match up with other things. And the final part of this first half is the very basics of copy and paste. And then I'll talk about the more advanced aspects of copy and paste in the next one. And actually, it's not copy and paste in Draw Exact, it's more sophisticated. It's copy, transform, and then paste. I'll show you what I mean. If I select that device there, and then select a reference point there, I can now do C for copy, and it's showing me what I've copied. And I could just stick one down there, for example. What's more interesting is that while it's in this mode, I can say, don't scale it 1, scale it to half size, scale 0.5, and I've now got little ones. I could say, well, I quite fancy one rotated 90 degrees as well. And you can mirror as well in there. So that's the basics of copy and paste. And I think that's where I'll leave you in this first half of the video. So I hope you feel that's going to get you started. But stick around if you want to see a little bit more of really getting the best out of some of these things and a bit more with a bit more advanced copy and paste. So here we go. If you're still here. Draw Exact always remembers the last thing that you've copied, even after you've closed Draw Exact. And if you switch between drawings, it has a shared idea of what was the last thing that you've copied, which is very useful because it means you can bring it back. There's a bring back command. And so a lot of people start creating library drawings. So say, for example, you drew stuff which needed lots of bolts and fasteners. You'd probably make a library drawing with a few hexagon heads and bits of thread and things, and split pins, and then whenever you wanted to use those in another drawing, you'd just open that library drawing, copy the thing you wanted, and then bring it back in another drawing. And of course you can scale it. So if you made your reference copies, for example, based on 10mm, it's very easy to scale it to 6mm by scaling it to 0.6. So you never really need to draw anything that you use often twice. So let me show you bring back. B for bring back. There's the last thing I copied. Now let's consider putting a set of copies of this thing along this line, but facing the other way. So I could mirror about a 90-degree angle, and I've got one facing to the left. I'm going to zoom out a bit, and then zoom in here. Make it a bit smaller. Scale. You can actually put a scale on the end. Scale down to, I don't know, 0.4. And then I can say, well, I'm going to have 16 copies. And it will show me a preview. When I go near something, it knows how to spread it along. So if I go near this line, it will show you what 16 copies would look like. I could change that to 10 copies if I didn't like it. Or if I wanted to put them along here, I'd need a different number of copies. But anyway, let's go back to 16. And that's a preview, but when I click, I'm committing. So that can save an awful lot of time, and it's also a very practical way of constructing lots of details. And that's a linear multiple copies, but it can also do the same thing around an arc. So while I've still got this on here, I've deliberately made it quite suitable for spreading around this arc here. I want you to notice something. When I go near this arc, notice that the end points of the arcs will be highlighted by blobs, but one's bigger than the other. So you see this end, it's got a big blob, whereas the other end, over here, it's got a small blob. You'll notice that, I'll just make slightly fewer copies, you'll notice that it's automatically rotated that object as it spread them around the arc, and it starts this end. So you first of all get the angle right using this thing here, so that it looks right at the beginning, at the big blob end, and then it will automatically rotate as it goes around the arc. So that's advanced copy and paste and bring back. I'm now going to show you a thing called a fillet radius. It's an advanced way of drawing arcs. I'm going to put a curve which blends in that corner, but I want to know roughly what radius I should use, and that's telling me on the readout that it's about 4.3, 4.4. So I'm going to first of all put in 4.4 up here, 4.4, and then I'm going to select the two lines between which I want the fillet, And there are some situations where there are multiple solutions, so I have to give it a guide point, which I'm going to say is there. Then I say F for fillet. There it is. Oh, it's remembered my style. And that's, I could just shorten these back to there to make a rounded corner, but I can also grow the arc. So you can think of it as just construction if you want. I can grow it into a bigger circle, or I can grow that into its full circle representation. I can grow that into its full circle representation, like that. Which I think you'll agree is pretty useful. And I'm not going to demonstrate all the use cases. I demonstrated it between one line and another line. I could have done the same thing between one arc and another arc, or one of each. If you do it with heterogeneous types and with arcs, there's often many solutions. There's one particular case where there's actually 16 possible solutions. And so what you do is you put in a guide point, and it'll choose whichever solution goes nearest to your guide point. And although that seems like quite an advanced feature, it's used a very great deal. So that's fillets. And the next one was ellipses. DrawExact can't do real, genuine ellipses, but it can do what's called a 4-arc approximation, which I'm always rather charmed by. It was invented by a chap called T.E. French, and I think 1915 or something, in the very early days of technical drawing. So I wouldn't recommend using DrawExact for creating isometric drawings, but occasionally you do need an ellipse, and we've got two types of support for it. You can draw an arbitrary rectangle and say, let's just go back to some more sensible, let's keep the properties of that. So if I just make a rectangle aligned with the axis, I can pick two of the edges and say, give me an ellipse, E for ellipse. And I'll show you what I mean. Although it looks like an ellipse, it's actually an arc at the top, an arc at the bottom, and an arc at either end, and they're blended to be perfect tangents here. Which it works pretty well if the aspect ratio of the ellipse isn't too far adrift, but if it's very long and thin, it's not so good. What's more useful is if you have, let's draw what a cube would look like in an isometric drawing. Just bear with me, please. I'm just going to get rid of that. In the final version of this, I will have prepared this. There we are, there's a cube as seen in an isometric drawing, and if it had a hole through it, you could say, give me an ellipse fitted into this diamond, like that. Again, it's no substitute for a proper 3D system, but it is quite useful to have, and I sometimes use that first type of ellipse that we had fitted into an orthogonal rectangle as a text label. Let's just show that, shall I? I'm just copying this piece of text. Scale it down a bit. Pop it in there. And this is quite an attractive type of label. You could have a call out coming along to illustrate something. Maybe put a blob on the end of that. That's got a common idiom. And I think that's probably everything I wanted to show you. Let me just check my script. Yes. So I hope you have fun with the real example drawings and making drawings of whatever type you're going to do. Please share them with us and please communicate with us. There's this menu up here for talk to us, get help. Then I wish you every success using it. That's it. Goodbye.